Hey, as a kid, I remember watching the first Iron Man movie and being fascinated with the idea of Jarvis. Jarvis, standing for Just a Rather Very Intelligent System, was a supercomputer that could not only multitask, but could complete tasks that in themselves seem very impossible to complete. However, supercomputers are outdone by their cousins, quantum computers. Specifically, photonic quantum computers. Quantum computing can enhance drug discovery through the modeling of the interaction between molecules and atoms. It also has the potential to decode all modern encryption methods by factoring large numbers quickly. Quantum computers can be utilized for many different fields, but before we use them, we gotta understand how they work. Quantum computing utilizes two quantum mechanics, those being quantum entanglement and quantum superposition. Quantum superposition. Now, imagine that you are strolling down the hallways of a school, and you come across a classroom. You want to know if there is a teacher teaching inside there or not. While the door is closed and you are not observing the classroom is in a state of being taught and not being taught at the same time. This multi-state position is how atoms act when not being observed. Once observed, they will choose one of the two positions. The utilization of quantum superposition allows greater variety in bits, which allows more information to be carried. Quantum entanglement. Let's continue with the classroom example. Your teacher and the teacher of your peer teach at opposing times. You and your peer both want to find out who has class during third period and who has class during fourth period. You go to class and see that your teacher is teaching during third period. Knowing that your teachers teach at opposing times, you infer that your peer's classroom isn't being taught right now. Just by simply observing your classroom, you were able to gain information about your peer's classroom. Now that we understand the quantum computing part, we must understand the photonic part. Light pulses are generated by lasers leaving these boxes. The lights go through these small circles called squeeze states. These create the photonic qubits. Photonic qubits are determined by the amplitude of the photonic waves. Further down the line, there are these sections where the light pulses interact with each other. This will lead to the maximum amount of outputs possible due to the interaction of the four beams. Measurements are made at the end through the use of photodetectors, which count the amount of photons present. All outputs will end up being entangled. The final measurement collapses all quantum states into one single outcome. This is known as projective measurement. This system not only makes quantum computing efficient, but scalable. Many of these processors can be connected to solve even more difficult problems. From this analysis, it seems like the future of computing is looking bright.